Day 587 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3531, count covered buildings. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. You are given a positive integer n representing an n by n city. You are also given a 2D grid buildings where buildings of I or xy denotes a unique building located at the coordinates xy. A building is covered if there is at least one building in all four directions, left, right, above, and below. Return the number of covered buildings. All right, y'all, so that sounds simple at first, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example one, we have our input n equals 3, buildings equals in a 2D array of integers of coordinates. First array 1, 2, next coordinate 2, 2, next coordinate 3, 2, the next coordinate is 2, 1, and the last coordinate is 2, 3. The output is 1. The explanation says only building 2, 2 is covered as it has at least one building above at 1, 2, which is right here, has one building below at 3, 2, which is right here. And just so you know, this is the 2, 2 building that is covered, and these are the 4 buildings that are in each direction. Then we have a building at 2, 1 right here to the left, and we have a building at 2, 3 right here to the right. So as you can see in this picture, right, we have this one building in the middle, and from this one building, we have a building in each direction, right? So it says a building is covered if there's at least one building in all four directions, left, right, above, and below. And as you can see, this green building is covered because it has a building to the left, a building to the right, a building above, and a building below. So that covers this building right here in green in the middle, y'all. So just in case that didn't make sense, let's go ahead and take a look at example 2. So in example 2, our input n equals 3, meaning it'll be a 3 by 3 grid. Then we have buildings at the coordinates in a 2D array. First coordinate is 1, 1. Next coordinate is 1, 2. Third coordinate is 2, 1, and the last coordinate is 2, 2. The output is 0. Explanation says no building has at least one building in all four directions. So up here, they give us our 3 by 3 grid. They give us a visual representation right here, and each X marks each one of these coordinates, right? And we only have 4 coordinates. So knowing that we only have 4 coordinates, we know that it's impossible to have a coordinate, have a building covered with a building in each direction, right? Because you would need at least bare minimum 5 buildings for this, right? Because you're going to need 4 buildings just to cover all 4 of the directions, right? And then you need a 5th building to be in the middle of those directions. So just the fact that this only has 4 buildings, we know that no building would be covered because we would need a 5th building to be in the middle of the directions. But either way, these directions form a square, whereas you can see up here, these directions kind of form more of like a diamond, right? So that's neither here nor there. Either way, the output is 0. And as you can see, no building is covered in this graph right here. So let's take a look at example 3. So in example 3, we have n equals 5, meaning this time we're doing a 5 by 5 grid. Boom, and the buildings equals a 2D array of integers. First coordinate at 1, 3, next coordinate at 3, 2, then the next coordinate at 3, 3, then the next coordinate at 3, 5, and the last coordinate at 5, 3. This time the output is 1. It says only building 3, 3 is covered as it has at least one building above. So let's look at the graph. So we have 3, 3 right here in green. It has one building above at 1, 3, which is right here. Or sorry, it says 1, 3. This is looking more like a 2, 3, or this would be 1, 3. So I don't know if that's above. I guess we're looking this way. So we have a building at 1, 3 right here. We have a building at 5, 3 right here. So yeah, I guess this would be the above and this would be the below. I don't know why they did it like that, but we have a building at 5, 3 right here. which is below. Then we have a building at 3, 2, which is right here. And then we have a building at 3, 5, which is right here. Boom. In the end, the visual representation lets us see that this graph is covered right here, or this building is covered right here with a building in all 4 directions. Now that we understand the question, hold on, y'all. I just want to see if they did the same thing here. So above would be 1, 2, or this 1, 2. Then below would be 3, 2. Okay, so yeah, they did it here too. So just imagine this is above, this is below, and then this would be to the right at 2, 1, and this would be to the left. Or excuse me, this would be to the left, and this would be to the right. 2, 3 would be to the right. So that means 3, 2 would, I don't know how they got these like this, but as you can see, either way, this building is covered, and you can see from the graph right here. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all, y'all. So let's get into it. Now, for each row Y, we're going to store the minimum and maximum X seen in that row. So to do that, we're going to come right here, declare a variable called X bounds, and we're going to set that equal to an array of tuples. So we are going to open up the parentheses. We're going to say min colon int comma max colon int. Then we're going to come outside and initialize it like this. So we're going to open up the parentheses. We're going to say repeating colon, open up the parentheses, and we're going to say dot max comma dot min. Then we're going to come outside of these parentheses, still inside the other parentheses, and we're going to say comma count colon n. Boom, just like that. Then we need to do the same thing, and for each column X, we're going to store the minimum and maximum Y values that's seen in that column. So this time we're going to say declare a variable called Y bounds, and we're going to set that equal to the same thing. Open up the square brackets, an array of tuples, open up the parentheses. We're going to say min colon int comma max colon int. Just like that. Come outside these parentheses, or outside the square bracket, open up some more parentheses. We're going to say repeating colon, open up the parentheses, dot max comma dot min. Come outside of that, still inside the other parentheses, and once again we're going to say comma count colon n. Boom. So now that that's settled, now we need our first pass, and which is to calculate the bounding boxes on both axes for all buildings. So we'll come underneath this and we'll say for B in buildings, we're going to open up the brackets, and we're going to convert one index input to 0 index grid coordinates. So we're going to say let open up the parentheses X comma Y. We're going to come outside of that, and we're going to set that equal to open up the parentheses. We're going to say B square bracket 0. Come outside those square brackets. We're going to say -1 comma. Then we're going to say B square bracket 1. Come outside of that and say -1 again. Now we need to update the min and max X positions for row Y. So we come underneath this, and we're going to say X bounds square bracket Y. Come outside of that, say dot min. We're going to set that equal to min, open up the parentheses, X bounds square bracket Y dot min. Sorry, y'all. Come outside the square bracket and put dot min. Then we're going to say comma X. Come underneath that, and we're going to say X bounds again, square bracket Y. This time we're going to say dot max, and we are going to set that equal to max, open up the parentheses, X bounds square bracket Y. Come outside of that, and we're going to say dot max comma X. Boom. Hold on. Let me fix this. This should be X bound, not S bounds. Now we need to do it for Y. And sorry, this should be lowercase x. Boom. Now we need to do the same thing for Y. So we're going to say Y bounds square bracket X dot min. We're going to, sorry, y'all, we're going to set that equal to min, open up the parentheses, y bounds, square bracket x, come outside of that, dot min, comma y, come underneath that, we're going to say y bounds, square bracket x, dot max, set that equal to max, open up the parentheses, y bounds, square bracket x, dot min. Sorry, y'all, let me fix this. Excuse me, not dot min, dot max. Come outside the square bracket, dot max, comma, y. Boom. Hold on, y'all. Let me clean this up. This should be a y. Boom. Now, we need our second pass, which is to count how many buildings are strictly inside both their rows, x bounds, and their columns, y bounds. So we come underneath this for loop. So let me clean this up. Boom, we're going to come underneath this for loop, and we're going to say return buildings dot count, open up the brackets, b in. Then we're going to say let open up the parentheses x comma y, come outside of those parentheses, equal, open up the parentheses, b square bracket 0, come outside of that, minus 1, comma, b square bracket 1, I'll come outside of that, minus 1. Boom. Now a building is covered if it is not at the min-max edge of its row and also not at the min-max edge of its column. So we come underneath this and we say return x is greater than x bounds square bracket y dot min. Come underneath that, we'll put two and signs. X is less than x bounds square bracket y, come outside of that, dot max, come underneath that, two more and signs. Y is greater than y bounds square bracket x, come outside of that, dot min. And then we're going to say, and two more and signs, y is less than y bounds square bracket x, come outside of that, dot max. Boom, y'all, that should be all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. And make sure it's still accepted after we submit it, because we all know how LeetCode can be, y'all. And look at that, y'all. 33 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.